Question number 8 from section 4.1 inverse functions. We want to determine whether the function is one-to-one. If it is, write an equation for its inverse and graph f and f inverse on the same axes and give the domain and range of f and f negative 1, f inverse. So this is the cubic function, x to the third with a minus 6. A cubic function, if you recall from previous chapters, one of the basic functions, and that minus 6 indicates that the graph has been shifted down. If you make a couple points, a table of values, and draw a couple points, we'll see perhaps that when x is equal to negative 1, you get negative 7. When x is equal to 0, you get negative 6. When x is equal to positive 1, you get negative 5. And you can continue. This is going to be a nice cubic function. You can plot that. 7, negative 7, 0, negative 6, and 1, negative 5. If you go too fast with this, you might not realize that this is actually a curved graph. It's going to go something like this. So is this function one-to-one? Well, it passes all the horizontal line tests, so we can say yes, this function is one-to-one. Now we want to find the equation of the inverse. The way you find an inverse for a function is to take the function, replace the f of x with y. So you get y equals x to the third minus 6. Interchange the x's and the y's. Where you see a y, you're going to put an x. Where you see an x, you're going to put a y. We're going to add 6 to both sides to solve for y. And we get x plus 6 is equal to y to the third. And to get y by itself, we're going to take the cubed root. It's the cubed root. If you had like a wide square, you would take the square root. Now we're going to take the cubed root of both sides. That's a little 3 over the radical. And we get the cubed root of y cubed is simply y equals the cubed root of x plus 6. And then the last step in finding the inverse is to replace the y with the notation for inverse. F inverse of x equals the cubed root of x plus 6. Okay, we're going to use this button on the math palette here, putting a little 3 for the cubed root and x plus 6. Now we want to graph them both on the same axes. Well, since I've already made a table for f of x, I can actually write a new table for the inverse. And the values, x and y values for the inverse are going to be in reverse order. So when x is negative 7, y is negative 1. Simply just reverse the order. When x is negative 6, y is 0. When x is 1, when x is negative 5, y is 1. And you can plot those points. 7, negative 1, negative 6, 0, negative 5, 1. If you wanted to do another point, like for the original function, when x is 2, you get 2 over 2 up 2, and then you can do another one here. So you're going to get this graph. You may need to plot a few more points to see the curve in the graph. And if we zoom in here, you see that basic cubed is the dotted blue line. That's our original function. The basic cubed function shifted down 6. And then the inverse has this curve here. So that is the correct choice B. Let me check your answer. Now talk about the domain and range. The domain and range for both of these, there's no restrictions, so it's going to be from negative infinity to positive infinity for both the function and the inverse. graph goes forever to the left and right in both cases. There's absolutely no restrictions. So that's the same as saying all real numbers. And the range, how low and how high the graph goes, is also going to be from negative infinity to positive infinity. Okay, if you want to look at that on the graphing calculator, the original function, I'm going to go to the y equals, typing in the original function, x to the third power, minus 6 is the original function. And then in y2, I'm going to graph the inverse, which we found to be the cubed root. The way you find a cubed root on the graphing calculator is by pressing the math button. And choice number 4 on this graphing calculator gives you the cubed root. And you're going to type in x plus 6. I'm going to graph these both on the same graph paper using the standard zoom. I click zoom and press number 6 for standard. And you see the original function and the inverse function. And there's a relationship between those x and y values. Every point that's on the original function has an inverse point on the inverse function. All right, let's look at the last one, number 9. For number 9, we're given a graph, no equation. We want to choose the correct graph of the inverse of the function. So the way you graph a function, or if you're given a function, you want to graph the inverse, is locating specific points on the graph and reversing the order. Like for example, this point right here looks like the coordinates are 10 comma approximately 1. It doesn't have to be exact. It looks kind of a little bit more than 1 if this is a scale of 2. That's going to translate to a point on the inverse, which has a reverse order. So the point 1 comma 10 is going to be on the inverse. It also has this point here, 0, 0 on the original function is going to correspond to 0, 0 on the inverse. And let's say we have this point right here. It's over, it looks approximately maybe like 6 comma of 0.5. It doesn't, you're going to reverse that order, 0.5 comma 6, to get a point on the inverse function. Now this is curved kind of this way. The inverse is going to also have a curve like that. Another thing you can do about these is to look at a reflection across the diagonal line. This point here, whoa, excuse me, sorry about that. Okay, this point here corresponds, use green, corresponds to this point over here. This point corresponds to this point. This point corresponds to, so it's a reflection across that diagonal line. And out of all the choices provided, looks like choice A shows the function and its inverse graphed correctly. Right, so inverse functions, there is a 4-step process for finding inverse functions. In terms of graphing them, it's easy if you have the table of values and a graph of the original function to simply rearrange the x's and the y's to come up with points on the new function.